85% of airport operational delays in 2025 still stemmed from human decision-making. Bottlenecks that AI can eliminate entirely. Yet fewer than 1 in 3 major airports globally have deployed predictive maintenance systems at scale. The ones that have a cutting unplanned downtime by 40%. This is not a technology gap anymore. It is a leadership gap. Think about what happens when a flight is delayed. Passengers miss connections. Crew scheduling fractures. Ground equipment sits idle. Fuel costs spike. For a major international airport, a single unplanned gate closure can cost $200,000 in lost revenue per hour. Singapore's Changi Airport processes over 100,000 passengers daily. One significant operational failure cascades through the entire system. Now multiply that across the Asia-Pacific region, where airports handle over 1.3 billion passengers annually according to 2025 IATA data. Most of these facilities still rely on fragmented systems, manual gate assignment, reactive maintenance, and human supervisors making decisions with incomplete information in real time. The cost of this inefficiency is not a technology expense. It is a competitive vulnerability. In this video, we are breaking down exactly how enterprise AI is reshaping airport operations from the ground up. We are not talking about theoretical applications or pilot programs. We are examining 3 proven transformation vectors that leading airports are weaponizing right now. Predictive maintenance and asset management powered by machine learning. AI-driven passenger flow optimization and dynamic resource allocation. And autonomous baggage and cargo systems integrated with real-time decision engines. By the end of this, you will understand the operational leverage these systems unlock, the measurable business outcomes, and critically, how to evaluate whether your organization is positioned to lead or follow in this shift. Point 1. Predictive maintenance is moving from reactive crisis management to proactive asset intelligence. For decades, airports maintained critical infrastructure on a calendar schedule. A conveyor belt runs until it breaks. A hydraulic system gets serviced every 2 years regardless of condition. This approach guarantees failures at the worst possible moments. AI-powered condition monitoring flips this entirely. Machine learning algorithms analyze sensor data from engines, electrical systems, baggage handling equipment, and runway infrastructure in real time. They identify degradation patterns weeks or months before failure occurs. Consider the 2025 implementation at Hartsfield-Jackson Atlanta International Airport. They deployed predictive maintenance across their entire baggage handling network using IoT sensors and machine learning models. The result: unplanned downtime dropped by 42% year-over-year, and maintenance costs fell by 18%. That is not optimization at the margins. That is systemic operational redesign. According to McKinsey's 2026 Aviation Technology Report, airports that implemented AI-driven predictive maintenance saw average equipment lifespan extend by 23% while reducing emergency maintenance incidents by 55%. Now expand this to the Asia-Pacific region. Changi Airport in Singapore, which handles 17 million passengers annually, has integrated predictive analytics across their entire terminal infrastructure. Their maintenance teams no longer respond to crises. They respond to early warning signals. Equipment gets serviced between flights, not during peak operating hours. Passengers never feel the impact. Operations run seamlessly. Here is how you apply this. If you are leading airport operations or supply chain infrastructure anywhere globally, begin with an equipment audit. Identify your most critical assets and highest failure cost items. Partner with a machine learning vendor to integrate IoT sensors and build historical failure datasets. Start with one system: baggage handling, ground service vehicles, gate equipment, and measure the ROI compounds across the network. Point 2. AI-driven passenger flow optimization is eliminating congestion before it happens. Airports are cities compressed into a few square kilometers. Terminals accommodate surges in passenger volume, security screening backlogs, gate changes, and interconnecting flight pressures. Historically, airport operations staff reacted to congestion in real time, managing bottlenecks as they formed. This creates stress for passengers, inefficiency for operations, and revenue leakage for the airport. Generative AI and real-time data processing now allow airports to predict congestion patterns at granular levels. They know which passengers are connecting through specific gates, what their dwell time will be, when security lines will peak, and how to dynamically allocate resources to prevent bottlenecks entirely. Dubai International Airport implemented AI-powered passenger flow analytics in 2024 and expanded significantly in 2025. Their system uses historical passenger data, flight schedules, connecting flight patterns, and real-time foot traffic sensors to forecast congestion points and automatically adjust resources. Queue wait times at immigration fell by 31%. Gate assignment algorithms now factor in passenger connection times, reducing missed connections. Passenger satisfaction scores improved measurably, according to recent Deloitte research on airport operations. AI-driven flow optimization generates a 2 to 3% improvement in on-time departure performance, a metric that directly correlates to airline partnerships, gate revenue, and passenger loyalty. For a major hub airport processing 50,000 passengers daily, that translates to substantial operational and commercial advantage. In India, Delhi Airport and Mumbai Airport have begun deploying similar systems to handle rapid passenger growth. India's aviation sector is projected to see 30% passenger growth by 2030 according to CAPA India data from 2025. Without AI-driven resource optimization, this growth would overwhelm existing infrastructure. With it, the same terminals can handle significantly higher volume without expansion capital. Application: if you lead airport commercial operations, invest in a unified passenger flow platform that integrates flight data, baggage systems, ground transport, and security. The software captures millions of data points in real time. Use GenAI to uncover non-obvious patterns about passenger behavior during peaks. Then let the system recommend dynamic resource allocation to ground teams. The output is not perfect. Predictions: it is better than human baseline decisions that operations staff can execute and refine. Point 3. Autonomous and semi-autonomous systems are reshaping ground operations and cargo handling. The last frontier in airport automation is not passenger-facing services. It is the operational backbone. Baggage handling, ground service vehicles, cargo movement, and aircraft towing. These operations employ thousands of workers, require constant coordination, and generate enormous cost structures. Autonomous systems, guided by AI decision engines, are beginning to reshape this entirely. Baggage handling automation has progressed furthest. Fully automated baggage systems now exist in multiple airports, including Copenhagen Airport and Singapore Changi. These systems use computer vision, machine learning, and robotics to move baggage from check-in to aircraft without human intervention. They sort by destination, track individual bags, and flag irregularities. They operate 24 hours without fatigue or error. According to IDC's 2025 Airport Automation Report, baggage handling accounts for 23% of airport operational costs. Automation reduces this by up to 40% while improving accuracy rates to 99.7%. That means nearly zero mishandled baggage, a metric that directly impacts customer satisfaction and airline cost structures. Cargo is the next frontier. Lufthansa Technik and other major cargo operators have begun deploying autonomous cargo handling systems in Frankfurt and Munich. AI-powered systems manage cargo manifests, routing, storage, and loading onto aircraft with minimal human oversight. During the pandemic, when labor availability became critical, airports with autonomous cargo systems maintained operations while others struggled. Southeast Asia is accelerating in this space. Singapore's Changi Airport has expanded its autonomous ground service fleet to include tug vehicles for aircraft movement and autonomous baggage trains. This is not novelty. This is operational necessity driven by labor market constraints and cost pressures across the region. Application: if you manage ground operations or cargo, conduct an automation maturity assessment. Identify roles that are repetitive, safety critical, or operationally inflexible. These are your highest ROI automation candidates. Start with one process, baggage sorting or cargo manifesting, and measure. Integrate the autonomous system with your existing operations management platform. This is not replacement of workers. It is reallocation of human attention toward higher judgment decisions that require expertise and adaptability. Picture the airport of 2027. A passenger arrives at a terminal where congestion has already been predicted and prevented. Security lines flow because staffing was dynamically optimized 2 hours earlier based on flight manifests and connection patterns. Their baggage is tagged, sorted, and loaded onto their aircraft by autonomous systems without human touch or error. If maintenance was needed on the baggage system, it happened overnight after AI identified degradation, not at 6 a.m. during peak operations. The aircraft itself communicates with ground operations via continuous data streams. Every decision the ground crew makes is informed by real-time intelligence about passenger connections, fuel loads, weather impacts, and runway availability. This is not science fiction. This is the... Thanks for listening. If you found this valuable, please subscribe to Apex Minds D4J for more powerful insights. See you in the next one.